Hello everyone, welcome to my class. I'm Dr. Ganesh from India. In this class we are going to discuss about the IP forwarding. What is mean by IP forwarding? The earlier video we have discussed about what is an address, what is an IP address, IPv4 and IPv6 addresses, and then how the DHCP protocol and NAT protocol, which is going to support for providing an addresses and moving a data between the network to network. So this IP forwarding is, we are going to discuss about how the packets are going to be forwarded towards to the destination and what is the procedure it is. Forwarding of IP packets. The role of IP address is forwarding. It means that with the help of IP address, that means the source and destination address, the packets are moving towards to the destination. That moving is, and we call it as a forwarding. So that forwarding between one node to the another node, which will be taken care by the data link layer and the network layer side from the source network to the destination network. So the forwarding, it is a place the packet is en route to its destination. That is where the packets can reach to the destination. So the forwarding is based on the destination address. So what is a destination address? How short and what is the shortest path it can able to reach to that destination. So automatically, which requires some forwarding tables. That forwarding tables which may have a host or the routers. And the packet is forwarded based on the routing table. So the routing protocol which is going to take care that how effectively it is going to derive that routing table. Because the switching and forwarding is going to do the process whatever it is stored in that routing table. Now the forwarding module in a classless addresses. In this you can see that there is one router. So there are multiple interfaces are there. So M0, M1 and M2. So which is going to maintain, this router is going to maintain on a routing table. In that routing table should contain that network addresses which including the mask, because it is a classless. If it is going to be classful, then it is no problem. If it is a classless, it must have the masking bits also. And then what is a network address? And this address is which is the shortest path to the next hop in an IP address, and what interface it belongs to. For example, if it receives some X addresses, it is trying to move to that Y address, then the router has to see that routing table, and based on the routing table, this is your next hop and you have to go via this interfaces. Likewise, which is going to move from, it is going to forward the packets from input port to the output port. Now here in this diagram you can see that there are two routers are there. The first router, there is an interface are M0, M1, M2 and M3. So in M0 there is an 180.70 connection, and M3 is a 201 and M1 is an 201.4.16 and M2 is going to be a 180.70. Likewise, which is going to be connected, this is an R1. So based on that addresses, based on that table, which is going to forward the packets. So now the address aggregation. Now you can see that in this diagram there are two routers, R1 and R2. The R1 is which is going to maintain the routing table which contains the organization 1 address, organization 2, 3 and 4 addresses. All such addresses with that interface is also going to be given. So this R1 automatically the next column which is going to mention that what is the next hop address. If it goes via the M4, then what is an interface? If it goes via the M2, then what is an address likewise. So at the same time, which is going to mention the interfaces. The same way the forwarding table at the R2, which also have the network addresses with the mask and the next hop address, or it may be a default router, and then what is an internet. This is how the address aggregation which is going to be there in that routing table. Now longest mask matching. What it means for longest mask matching is that particular router, how many number of devices are going to be given in that the private addresses. So based on that, the longest mask it has to use so that it can able to identify that the universal addresses. Based on that, by seeing that routing table, it can forward to the next hop address with the interface information. Next is a hierarchical routing with the internet service provider. Say for example, if any one internet service provider, he may be covered the entire country. So as like our postal addresses, the first which is going to have a entire country region, and then province level, and then district level, and then city, and then local, and then organization level. The same way the address is also going to be assigned here. For example, here you can see that it starts from right hand side, right to left we are going. In the right hand side there is a regional internet service provider address is there. So that address, how many addresses it is there. So from that which is going to connect it to an internet. So from this there are many local ISPs are going to be connected. So the first local ISP that will be connected to multiple small ISPs. So that small ISPs, each one may be given to every other organization. So that private addresses can be given by this classless address can be given by the regional ISP. So one regional ISP can give multiple numbers of local private addresses to the all other branches. The same way which is going to be replicated for each and every local and then small, likewise it will goes on. The same way we can able to give a huge number of connections with the same addresses. This is how the hierarchy routing with an ISP is going to be there. Now we can see that how the forwarding is based on the label. We all know that in that packet switching, which is going to have two types of switching. One is a datagram approach, another one is a virtual circuit approach. In 1980s, the IP to behave like a connection oriented routing. Those days it will be like a connection oriented. It means that the datagram kind of approaches, which was replaced by the simple switching concepts. So the connection oriented network in a packet switching is a virtual circuit approach mechanism. It means that all the packet which is going to follow in the same path. So a simple switch can able to forward some packets based on the label which is placed in that packet, which is attached to that packet. Based on that, which can easily forward the packets towards the destination. So the routing is normally based on searching the contents of a table. So switching can be done by accessing a table, which is going to access the table, whatever it is available. With that help, which is going to simply forward it. So the routing involves searching and switching involves accessing. So the routers as a packet switch, there may be a datagram and the virtual circuit approach method. Now we can see that how forwarding is going to be happen in the both in datagram approach as well as a virtual circuit approach. The forwarding based on the destination address. Here you can see that with the mask, so how many number of bits are going to be used in a classless addressing mechanism, 32 minus n. So based on that, which is going to use the mask number of bits. So it has to decode it, and then which is going to be getting from the mask, it is going to get an original network addresses. From the network address, which is going to identify the routing table, which is going to identify which is the next hop addresses, and that particular next hop address is connected to what interface it belongs to. The same way which is going to perform in the forwarding based on the destination addresses. Next is forwarding is based on labels. If it is going to be a connection oriented, so here it can able to use only switches itself. So labels used as a indexes. So as if you can see that 0004, that has to be which was indexed in that table, switching table. So that particular table which is going to be interfaced in the port 2, and what is the next label it has to move, that is an 0012. Based on that, it can move to the interface label address to the next node. Next is we will be seeing that multi-protocol label switching header. So MPLS header, which is added to an IP packet. So whatever the IP packet which is going to come along with that, the multi-protocol which is going to be used, the multi-protocol label switching. So which is going to assign some labels along with your original data. That data will contains an IP header and then IP payload. Apart from that, MPLS headers are going to be there. This is an MPLS header made up of stack of labels. It may have a multiple stack of labels. It is not only a single label, it may consist of a multiple labels are going to be there. And then what is then time to live, how much time that particular packet has to live in that packet also going to be mentioned. So to forward that packet, these are all the things are required. So let me recap that what we have covered here is, in this class we have seen that what is an forwarding mechanism and what is in switching, and switching is going to be ultimately accessing, and whereas in a routing is which is going to be an searching for the shortest path. So in this packet switching concepts, there are datagram as well as a virtual circuit approach method. In this datagram approach method, it can be used as a router can able to use it, and how it can able to use a classless addressing can be forwarding the packets to the destination. And then we discussed about in the virtual circuit approach, simple switching can able to do that process by moving from the source to the destination. Hope you understood the concepts. If you have any queries, you please type it in my chat window. I'm happy to respond to your queries. If you don't subscribe to my channel, please subscribe to my channel. Thanks for watching my class. Have a great day. Thank you.